Microlecture 7: The Scientific Revolution. In this microlecture, we will try to understand what major scientific developments happened in Europe between the 1500 CE and the 1700 CE. Our goal is to try to recognize why Europe ended up being an essential center of knowledge during those years. The European scientific revolution did not happen in a vacuum. From the year 1000 CE to the year 1500 CE, some parts of the planet experienced a period of cultural and intellectual flourishing in which scholars from the Muslim world, China, and India developed areas such as mathematics, physics, astronomy, medicine, and algebra. Additionally, in places like Baghdad, Cordoba, Cairo, and Marrakech, universities were established to promote the free discussion of ideas and the circulation of knowledge, including the preservation of Greek texts only available today thanks to the open mind and tolerance of Muslim scholars. China was also a vital center of scientific activity. Among its achievements, we should mention the invention of paper-making, gunpowder, and instruments to navigate in the sea. What all this scientific activity implied was that it was not inevitable that Europe will take the lead in scientific thought. As Europe recovered from the destruction of the Black Death in the 15th century, the intellectual and cultural movement known as the Renaissance provided the foundations for the scientific revolution. Scholars known as humanists promote knowledge for the practical purposes of life. Their quest to restore the glories of the ancient past led to the rediscovery of texts first produced in the classical world and a vast interest in knowledge. It was in this period when European universities began to establish professorships of mathematics, astronomy, and natural philosophy. These new fields were not significant at the time. Still, the creation of classes on these topics reinforced the need to integrate science with natural philosophy, something that was at the base of the scientific revolution. Another element that catalyzed the scientific revolution was the overseas expansion of the Europeans during the 15th and the 16th centuries. This expansion contributed to the development of new ideas about the natural world, transformed navigation, and stimulated research and innovation. In this context, instruments such as the telescope, barometer, thermometer, pendulum, clock, microscope, and air pump were invented. All these inventions have in common that they allow a better observation of the natural world and its behavior. The printing press was another crucial technology developed at this time. It provided a faster and less expensive way to circulate knowledge. Until 1550, most European scholars believed that philosophy was the path to real knowledge about the world. Based on the ideas of Aristotle, they thought that a motionless Earth stood at the center of the universe and was encompassed by 10 separate concentric crystal spheres in which were embedded the moon, sun, planets, and stars. Beyond these spheres was heaven, with the throne of God and the souls of the saved. Aristotle also dominated thinking about physics and motion on Earth. The elements air, fire, water, and earth were the substance everything was made of. The first major departure from medieval understanding of the world happened with the Polish cleric Nicolaus Copernicus. He was the first European who openly claimed that the sun, rather than the earth, was at the center of the universe. His most famous work on the revolutions of the heavenly spheres was published in 1543, the year of his death. The German mathematician Johannes Kepler was also very influential in the early development of modern scientific thought. Kepler developed three revolutionary laws of planetary motion. He demonstrated that the orbits of the planets are elliptical. He showed that the planets do not move at a uniform speed. And finally, his third law states that the time a planet takes to make its complete orbit is precisely related to its distance from the Sun. Kepler's contribution was monumental and truly revolutionary. Drawing on his predecessor's work, the Florentine Galileo Galilei challenged century-old ideas about movement and motion. In his famous acceleration experiment, he showed that a uniform force, gravity, produced a uniform acceleration. By 1640, the work of these scientists was widely accepted despite the massive opposition of religious leaders. However, their findings failed to explain what force controlled the movement of the planets and objects on Earth. That challenge was taken up by English scientist Isaac Newton. He used Kepler's laws, Copernicus' astronomy, and Galileo's physics to develop a single explanatory system. His work, Mathematical Principles of Natural Philosophy, changed modern science forever. Newton's main accomplishment was the law of universal gravitation, which proved that the universe functioned according to rules that could be understood and expressed in mathematical terms. At the same time, several European countries embarked on a pursuit of knowledge about the unknown geographical regions of the world. The Spanish Crown and other European powers sponsored scientific expeditions to gather information and specimens, out of which emerged new discoveries that reshaped the fields of botany, zoology, cartography, among others. By the end of the 17th century, the scientific revolution transformed how people think about nature, the world, and the universe. Its impact can help us understand why scientific progress was thought to be essential to improve the human condition. This is all we have for today. Thank you, and I'll see you next time.